like focused on is that let's avoid the title. The title doesn't mean anything. I've met 17 DevOps engineers in the last 2 weeks, and they all do different things.
Okay.
Instead, let's get conversant on the skills that you are a master of, or you're intermediate at, or that you're good at. That's what we should be focusing on. And when someone comes to you and says, hey, how can you prove what you're doing? You should have a project that shows a CI/CD, like for example, that has Ansible, Docker, and Kubernetes in it. And then you can say, this is what I built, right? I've got 3 versions of it. One of these run on Windows, one of these runs on Linux. And so that's my point, is that let's throw the title out. Let's just be very specific about what we're skilled at and what we know nothing about. I mean, someone the other day asked me, do you know anything about RedCap? And I was like, no. They're like, really? Nothing? I was like, no, I don't know anything about it. What about Kafka? I was like, I've deployed Kafka once or twice, but you don't want me touching Kafka. I'll wreck it for you. And then that way, when people are interacting with you, they're like, or, it's like really specific. And then someone else is like, what about Elasticsearch? I was like, oh, I know Elasticsearch really well. Like, I can help you with Elasticsearch. And then that way, you're never in a situation where you either have an intentionally built skills, or you are in clear agreement about what you do and don't know. Like that guy who asked me about coffee, he's like, well, I want you to come help me anyway. I'm like, are you sure? Because I don't know shit about Kafka. Like, I really don't. Are you sure you want me to do? And that's not true, right? But then he was like, you know nothing, but you have a better attitude and you've got background on other technologies. So instead of focusing on titles, let's focus on skills. What skills can you proudly say that you are a beginner at, an intermediate at, and which ones can you stand there and be like, dude, VI. I can write macros in VI blindfolded underwater, right? But of course, nobody cares about VI. But my point being is that whatever it is you're good at or intermediate, let's just be honest about it, right?
Okay.
And that's it. And nobody cares what you did 10 years ago. People only care about what you've done in the last 5 years, right? So,
okay.
Yeah.
So as long as you have conversant beginner skills in Ansible, Docker, Kubernetes, and then Windows and Linux system administration is just assumed.
Yeah. Basics on command line and system administration, those are assumed, right? So that roadmap is useful for as far as some of those basics, right? But that will get you in the door as like a sysadmin DevOps engineer. It'll get you in the door, but then you got to know what most people do is they get a job and they just start coasting, and it's like you can't do that in the IT industry because you'll be out of date in 2 or 3 years, right? I can't tell you how many people I meet and they like haven't touched a new technology in 4 or 5 years. And then I bring up things like Docker and they're like, oh my God, that's so bleeding edge. And I'm like, no, it's 7 years old at this point, right? So, and more, and like, I remember who put that down there, Trevor. Yeah, more important than any of this is the number one thing that will raise your IT career is basically your communication skills and your ability to persevere in the face of absolute ridiculousness. That is the number one thing. Yeah, because what's going to happen is the system's going to fall over. Someone will have touched it. You won't know because you don't have change control and you don't have monitoring, and you're burning $1,000 a minute every time that system is down. And someone's going to see there and be like, "I need you to fix this." And your first thought is, "I'm not fucking responsible. I'm not responsible for this. Why are you looking at me? I don't even know anything about this." And it doesn't matter. Like, it doesn't matter. You're going to be put in ridiculous situations. Even without the stress, someone's going to come to you and say, I want you to stand up this, 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 and this. And you're going to be like, that's ridiculous. You are not going to get the outcome you're looking for if we do that. And they're going to be like, I don't care. Do it anyway. You'd be like, okay, as long as we're clear. Right? So yeah, so communication and basically perseverance are probably like the 2 most important things. And I mean communication, like being responsible for how stuff lands, how you say things, and how you receive things, right? It's going to be really important. That's actually probably more important even than the tech. So, yeah.
I have one thing, and it's more of a statement. It's really quick. So for me to, if you want to start working with YAML, I know what helped me a lot was working with Ansible, because you were just going to be troubleshooting for days over spacing and things you didn't type correctly. So what he said is, set up your own personal lab. I used GNS3 when I started and just put like a Linux host on there and then ran Ansible off of it. And then I bought some hardware and did it off of that. But like I said the other day, to this day, I still have spacing issues. And with IDE, without IDE, I'll still have spacing issues. So if you want to work with YAML, try working with Ansible, and then you get the knowledge of Ansible while getting YAML at the same time.
Thank you for all the good advice. Appreciate everybody's picture. Thank you.
I do too, actually.
Attitude makes a big difference.
Hey,
If I have attitude, I don't know anything, I can still get nothing done.
Hey, I just wanted to add on there. I've been doing this for about 20 years, and I've interviewed people for years and years. And I will say that I absolutely agree that you have to keep in the IT world. If you're not taking training every year, there's a definite problem, and it will show in the interview. And so you need to always keep those skills up. And don't try to pass yourself off as something you're not, because if it doesn't show up in the interview, it'll show up that first day you're there. And yes, you will be asked to fix something that you know nothing about.
Yeah. And you can't judge it, right? Everyone's just trying to survive. We really literally are all doing our best, right? No one's trying to hurt anybody else. No one's trying to really screw anybody over most of the time. Right. And we really are just trying to do our best. And the businesses are just trying to survive. Remember what I said before, businesses are the worst gladiator sport in the world. 95% of them are done in 10 years. They don't make it. Right. And the ones that are there have to fight to stay there. So yeah. Good. Okay. So that's a great discussion. We could do that all day, but we're not. We could though. So we're going to roll into lab 9, but I just want to remind you of a few things before we roll into lab 9. That feels kind of mundane after the whole piece. But once again, we're going to be, so this starts out at WAS admin. So if you ended up as root, probably want to get out. Make sure that if you have any other terminals open, that anything there is closed, right? Hopefully Minikube has already started, so you're not going to wait the 5 to 10 minutes to get that thing going. And then what's going to happen is that you're going to actually set up another pod. And you can actually, by the way, modify an existing YAML that you already have if you want to. But what's going to happen is you're actually going to use the node selector to literally say where quality equals best node, right? And so like this is what's going to happen. So what's going to happen is that then you're going to basically edit that, apply it. So you're going to launch the pod. You're going to see it going. And then what's going to happen is it's not going to launch. Why? Did you label anything? Right? We didn't label anything. So what's going to happen is you're going to describe the Minikube node and then you're going to label it, right? And look what you're going to label it. Exactly what you think you should, because that's what you put in the pod specification as the node selector. And then you're going to describe the nodes, and then guess what's going to happen? Given just a minute or two, it's going to roll over, right? And then what's going to happen is that you're then going to start doing some setup for pods based on resource availability, which is actually a really great thing, because I'm just going to tell you right now, please do not run anything in production without setting resource limits. I don't care if you do it on the namespace or if you do it on the pods, but at the very least, do it on the namespace. Say, look, this namespace can only handle 4 processors in, 1,000 gigs of RAM, a gig of RAM or whatever, right? So just something to be reminded of. So as you do this, you're going to do it at the pod level. Just know that you can also set limits on the namespace level as well, right? So you're going to be looking at a bunch of things, right? And then you're going to edit the scalar deployment, basically, which is just Nginx. And then notice here, look at this stuff right here. Look at these. You're going to set a hard limit, which said this is the maximum number of resources this system can consume, this pod, right? And then you're going to set an initial request, which says I want to start out with 64 or 125. By the way, how many M's equal 1 CPU there? Someone tell me, how many M's?
1,000? Sorry.
That's right, milli CPU, right? So just know that when it says 125 M's, that's what, 1/8 of a CPU. That's what they're asking for. 250 is a quarter of a CPU. So, just something to be mindful of. So you're going to basically set that up. You're going to deploy it. You're going to watch it go out. You're going to look at the CPU requests. And it's going to show you some of the math that we actually follow, right? And then you're going to scale some replicas. Look at that. So you're going to go to 10. Now, why are they doing that? Well, they're trying to basically overwhelm your system, right? For a second. So it looks like, by the way, only 9 of the 10 pods being available is what will happen, because it'll basically run out of something, right? What's the something? So it's going to walk you through that whole piece, show you everything that's running except for maybe one of them. By the way, you can scale it up and down to drive it even further if you want to go like to a 12 or 13 just to see what it does, or go back down to 8 and see what it does. And then you're going to basically describe the pod in question, the one that's failing, and it's going to say, hey, insufficient CPU. So it's going to tell you. Now remember this command, the describe pods command, because you can describe anything. And if you ever need to like look at what's going on with a particular object inside of Kubernetes, you're probably either going to describe it or you're going to get it with a -o wide. Either one is going to give you some information. Okay. Then you're going to describe your node and look at the allocated resources for your particular node. And then basically from here, that's it. It's just that simple. Okay. So let's go forth and conquer the next lab. But we're going to do lab 9, and let's see. I was going to check on this because we are going to do networking next. I think if it's okay, let's go ahead and do lab 10 as well. So let's do lab 9s and 10. Let's just do lab heavy this morning. Let's go ahead and knock these out. Lab 10 is going to basically have you playing with some networking, and then we're going to talk about networking. So I'm going to have you play with it first before we talk about it. Okay. So that's what we're doing. Labs 9 and 10. Usually this takes about 45 minutes to an hour to run through. So same thing, please run through it. When you're done, click on reactions and give me a checkbox so I know you're there.
I can have a question.
Go ahead.
So I did my lab 10, sorry, 9, 9 yesterday, just to see like how I'm able to grab it, understand it. What does the status image will back off? What does that mean?
It means it was trying to pull the image and the back off timer kicked in because for whatever reason, it wasn't able to pull the image.
Okay. So
Yeah.
I can just, when I get something like this, I can read on it.
Absolutely. Yeah. And so what you can do is if you want, you can either look at the Kubernetes documentation for pods to see what, like go to the kubernetes.io, go to documentation and look for like back off, right? Look for the particular error message. Sorry, my brain. And you can look there and it will actually tell you what that error message means, right? So I wouldn't Google that per se. I'd probably start with the Kubernetes documentation first. If you don't find what you're looking for, then broaden it out to Google. Typically either Docker or Kubernetes documentation is going to have what you're looking for.
Okay, so this is something what I encountered in a training, in a exercise. But let me get there and I'll share my screen. Thank you.
Okay, that's fine. Sorry, I was fully paying attention. I was just looking. At
No,
the
it's okay. I just want, because I thought I did something wrong. I've tried to follow direction, and I agree. When there's a page, when the page comes in, it's so much difficult to write the whole generate file, YAML file. Oh my God, that was a nightmare. But it was a good learning experience.
Good.
Thank you.
It is a nightmare, and I'm glad that you think that you appreciate that it's also a good learning experience. It is tough. It is tough, actually. Just to say this is that if it's backing off on image pull down, it might be because the image name is incorrect, like in the pod YAML. That would be one reason, or it could be having a problem pulling because maybe hub.docker.com is rate limiting it. So describe the pod and see what message you got for the pull off. If it says, hey, message says, rate limiting or whatever, then yeah, we might have to log in with the tokens again.
I was having the rate limiting last night. I haven't tried it this morning.
Just in Docker in general or with Kubernetes?
With Kubernetes. When I would do the Docker login, it populated the Docker config JSON, but inside of Kubernetes, it was not, it still wouldn't pass that credential.
Oh, yeah.
Do we really need to delete Minikube, or is it okay to just use the one?
No. Don't delete Minikube. No, don't.
Okay.
You don't even have to stop Minikube. Just leave it alone. Yeah.
Okay.
It was already running, so you don't necessarily need to follow those directions.
Yeah, I was going to ask about that too. I didn't delete mine yesterday.
Yeah.
That's the only thing I kind of skipped.
Yeah. Skip that whole step around stopping and deleting.
Okay.
Yeah. By the way, as far as the kube linter, I gotta tell you that StackRox, I almost worked for them actually. They are a spectacular company. I actually flew out to California and had an interview with them out in San Jose back in 2019. They were a great company. A little tense for me, but They got bought by Red Hat actually, so they're now owned by Red Hat. But that Kublinter that they have is absolutely spectacular. And the other thing is that StackRox publishes a comparison between all 3 managed service Kubernetes providers, which I'll post in chat. If you haven't seen that report, you should keep that on hand because it tells you exactly what the differences are between the 3 major cloud providers in their Kubernetes installations. So it's really good. Are there any other questions or comments that I missed? Because there were some really good ones, and I don't think I responded to everyone in chat.
Yeah.
Paul, your question, is there a term for a non-feature programmer aside from a non-feature programmer?
Yeah.
We used to refer to ourselves as hackers, but now that means something else. So script kiddies, no, that's not right. That means something else now too.
Yeah, I used to be a software engineer, and I didn't really like the feature programming type of thing. Every 2 weeks, new sprints, etc. And I didn't realize that non-feature programmer was even like a term until this morning. So I'm wondering, like, is there an actual official term so that I could explain to people, yes, I want to be a programmer, but not for features.
Yeah, so usually what I say is that I'm an infrastructure like software engineer. Like I put a prefix on it, so it's like they know that I only do software engineering for infrastructure, right? Which is typically what DevOps is mean, but DevOps has gotten so muddled. So I usually just say I'm an infrastructure software engineer, and they know exactly what I'm talking about. They're like, oh, what do you mean? Like Ansible, Terraform, that kind of thing. Oh, they're like, oh, yeah, that makes sense, right?
Okay.
That's what we need is another term. I'm sorry, I just added to the chaos. All right, I'll leave you to it.
Question. Let me see if I can.
And then this starts.
Sorry,
This starts up a new. This has nothing to do with the containers.
Gotcha.
Yeah, it just basically tells the template how to pull the containers.
Yeah, looks like I do have that. It's still not working.
What does the scribe say is the problem?
It says error parsing scalar deployment.yaml, error converting YAML to JSON.
Okay, so there's a format error in there. That's usually what that means.
Character found that cannot start at any token.
Okay.
Okay, let's see if I just have extra.
Yeah, so that's basically telling you there's a format error inside the scalar deployment YAML.
Try it one more
time. Mike, do you mind if I share my screen?
No, not at all. Let me just check. Anthony, are you good at this point? Yes.
Yes, I am. Thank you.
Cool. All right. Yeah, go right ahead.
Cool. Because it's kicking my teeth in a little bit. What do you see?
The main challenge I see is that you have backslashes instead of forward slashes inside your directory definition. Yeah. So see where it says /home/wiseadmin, just change all those to forward slashes.
Got it.
Yeah.
Every time.
You could set that or just stop using Windows.
No. No, don't be like that. Windows has its place. I know.
I know.
Yeah.
Or just stop using Windows. Yeah, that's practical. It's only like 90% of the desktop OS market.
You know, I mean, you could get away with it, right? You could get away with it. I hear you. But yeah, you know, I have all
You
three.
get away with murder too if you're really good at
it. Yeah. Oh, well, and Windows is useful for gaming, actually. So let's see.
Actually, you mentioned gaming, but I've been testing Steam with the Proton compatibility layer on Linux lately, and it does actually work quite well.
Oh, that's cool. That's something I was going to follow up on, actually.
Yeah, I was quite pleased. I was able to install and run several Windows-only games on my Ubuntu installation.
Oh, that's awesome to hear, actually. Let's see. So when you run that, what does it say? Jonah?
Did you see that?
Yeah. Take the backslashes off. There. Yeah. Take the backslashes off for just a second. Doesn't like something here. Dash type, that all looks good. Config.json looks good. Yeah, there we go.
Okay,
Yep.
cool. Thanks.
Yeah, yep, should be good.
I wonder if I should do the same thing.
Yeah, and let's see. As far as the credentialing goes, just to confirm for Mark, that is definitely it. So, right. If you're getting that the password doesn't work, Mark, just to check with you really quick.
Yeah, it says got permission denied while trying to connect a Dr. Damon socket at Unix, blah, 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 post, blah, 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 blah.
Oh, yeah.
dial.
That's not a password problem. All right. So you're WAS admin right now, right?
Yeah.
Yeah. So I don't know if you saw us switching to root to run the Docker command. And then what ended up happening is that because we ran the command as root, we had to copy the config.json into the home directory for WAS admin and change the ownership of it to WAS admin. That's what we were doing. And the reason is that the permissions on this are a little weird, and that basically WAS admin hasn't been enabled to operate as a Docker user. So. So just a reminder to everybody is that the example YAML file has been posted up in chat, right? And the source link for all of this information has also been posted up in chat. So feel free to grab it. But this is an example of where you would put the image pull secrets that I just posted in the chat. It is not a file that you're going to use. It just shows you where to stick image pull secrets in alignment with containers.
Oh, that's why.
Oh, Matthew, if you want to do it on the command line, I don't think you can actually. Because how would you do that with all the Kubernetes boxes? You actually have to create a secret. You can't force that to happen on the command line. The problem is that it's not going to pass that across the wire, right? So there probably is a way, but I would highly not recommend against that. I think there may have been a section in here about how to do that. Oh yeah, there is actually. But that's just creating the secret. Yeah. Yeah, the problem is that they're not gonna let you pass username passwords across the wire. So you know, you have to create a secret for that to work.
You know, Lab 10 does a command line deployment create, and the question, and so you're saying we can't list image pull secrets in the command line, like say, because of that. So we'll have to make another.
Actually, you know what? I didn't understand the question. That I don't know. Actually, hold on. Let me look for a second.
Yeah, Lab 10 Part 3, and there's probably, I'm sure some more of these labs are doing the command line.
I know what you're asking, because you're like, hey, I'm doing an imperative command where I'm basically saying just create a pod for me. Can I specify a secret on the command line? That's a great question. Actually, I don't think I've ever done that. Let's go take a look.
I thought you can.
You can create a secret on the command line, no problem. But when you go to create a pod, is there a way to specify that I need credentialing to do this, right? And so
don't you add it to the default service? Add that credential to the default service?
Well, you're creating everything on the command line. So you're actually creating a pod right then and there. So then is there a way to specify a secret, for example, on that command line so you can actually just grab it from there? Because I'm pretty sure they won't let you do a username and password, because then that has to be passed to all of the Kubernetes nodes, right?
If you do the get service accounts.
That's just create like identities for your submissions.
Gotcha.
So
Okay.
I don't, yeah, for like serve, like for example, running pods, you would still have to create a secret for the reg cred.
Oh, crap,
So,
I'm
Joe-
just not muted.
That's all right, Jonah. We heard your celebration. It's all good.
YAML got me again. Spacing. And then
It
I
does.
finally like tabbed it and I was like, it works.
All right. Can I share and troubleshoot this? I'm missing something silly.
Sure. Hold on. So Mark, I just saw your thing as well. So yeah, Trevor, go ahead. We'll do yours and then I'll roll over to Mark. Image pull secrets aligns with containers. Yeah, I was actually just looking at that. Okay.
Where are you gonna go next?
Oh, you're still having the problem?
Yeah.
Can you do a get secrets? Okay, so it is a Docker config.json. Did you reapply the scalar YAML to your deployment?
I believe so. That's there.
Okay, so retro is there. Can you show me your config.json? That looks right, actually. Hold on, just confirm that. Hilarious. Just realized that I had JFrog in there as well. But yeah, okay. Auth look right. That all looks good. All right, so your credentials are in there. You have to put deployment in front of the scalar deployment.
No typing. Oh, it did take it. Oh, that's interesting.
Well, it's got, because if it has enough information to derive, it will.
Okay.
You actually don't have to put the whole name in there. Okay. Okay. Do a get pods now. Wait, what? Just said set it up to 1. Oh, sorry. Get the pod, not the deployment. Sorry. Oh, that's interesting. Error on the image pull. Okay, yeah, keep going. Just yeah, scalar dash deployment.
This is like third time this morning. I actually just restarted and tried to clear out everything. And I'm back to the same.
So you're still getting a rate limit. Doesn't is it actually using the credentialing? That's kind of interesting. Let's see. Go ahead and describe your deployment again. Nothing is listed there. That's weird. Why is it that no secret is listed underneath that? Let's see. Let's describe the secret just to make sure. So go in and kubectl describe secrets slash regcred. Is that right? Okay, cool. In default, nothing listed there. Standard type config.json. Okay. I gotta say that one's a stumper. Actually, I would probably delete everything and start over, frankly, because something's wrong. Because it should be authenticating. I'm authenticated, and it's so because I thought maybe I hit like the 5,000 pull limit, but that's not happening because I actually just pulled and it was totally fine. So something's out of alignment here. Either the secret is out of alignment or the deployment is out of alignment, but we're not getting. It doesn't seem to be resetting. So one thing that we might do first is actually just delete the deployment and reapply it just to see if something else is happening, right?
I noticed that the size of his file is different than mine too. He's got 179 bytes. I've got 135.
I mean, I'm able to pull. So
Right, that's why I'm saying I don't think there's anything wrong with the login. For some reason, it doesn't seem to be using the secrets credentialing.
Okay.
That's the thing that's a little weird. So what I might do is delete the deployment because it looks like everything around the secret is totally appropriate. I looked at the config.json, that looks solid. It is defined as a config.json inside the secret. Everything looks solid there. So what I might do is delete the deployment. So you can just delete and then -f, the scalar thing and just reapply it and see if that helps. I'd be shocked if that was it though. It shouldn't get hung up on that. But when in doubt, nuke and repave. That's usually what ends up happening.
it should, when you do the apply, it should override it anyways.
That right. It should amend it actually, right? So
Yeah.
But it doesn't seem to be reading the secret for whatever reason. So I'm going to assume that that doesn't happen very often, but it seems like it's hung up. Well, hold on, stop for a second.
I'm still back on lab 9 and
so hold on one second, please.
Okay.
So the kubectl delete that you just ran deleted the deployment, but it doesn't look like it like you still had a deployment available, right? Or was that another deployment that you were?
It was a different.
Okay. So NX1 was expected.
Yeah, well, I mean, same situation. I can't pull the image anyways.
Okay. Okay. So I just wanted to check. Cool. All right. And I'm sorry, who was that talking just now?
it was Sean. I was just saying that I got a pull denied error back on lab 9. So having the same issue, I think.
as far as like using credentials to authenticate against the registry?
It just says there've been too many pull requests and I have to wait.
Did you already use the secrets and all that in order to get authenticated into Docker? Sean?
No, I'm pretty far behind the rest of you guys because I got here late today.
Ah, okay. All right. Well, that link that we have that that I just listed about pulling the private image registry, that is the link that basically that we're following. It's basically 3 steps, which is 1, we are basically creating a Docker like a config.json for Docker by basically logging in like we did before with the Docker login. And then what we're doing is we're actually then, because we had to do that as root instead of wasadmin, we are copying the config.json into wasadmin. And then all we're doing is creating a secret off of that config.json. And then we're referring to that secret into the like pod specification. So it basically shows you, which is not like part of the, like, it basically shows you how to log into a private registry. That's what it does. Okay, so what happened? Trevor, what happened with your stuff just now?
Nothing. Same thing.
Same, so it's doing the same thing? Okay. So you're able to pull from Docker, but it's not reading for whatever reason. So can we go take a look at your YAML one more time? Just to make sure that we're not missing anything. We didn't throw any errors, so this looks legit. Regcred is indeed the secret. It is image pull secrets. There's the name. Nginx 1.2.1. Is that what it says in the lab? Is Nginx 1.2.1? That's impressive. I didn't even know they were going that far.
I think it says latest. I was playing, and that's one of the reasons why I was looking for the list tags so that I could get that just to see.
Oh, so in the lab it says latest?
Yeah, I think so.
Okay.
But either one, it's in the local
Yeah, it's in the local
cache. It should pull it.
Yeah. Well, I don't really have an answer for this problem. I'm not sure why it's not working, honestly. Again, that is really strange. There's some like, so at this point, what I would do is I would undo everything. I would delete the secret. I would delete the deployment. I would delete the YAML file. I would literally start over because there's something that we're missing because this works, right? And it's working for other people. So it's like, I cannot see what the actual challenge is. And so when that happens, I usually just keep backing up destructively until I figure out, because then I have to like start over basically.
Okay.
Yeah, and that's invariably every time. That's what has to happen. So I don't really have a good answer for that. Sorry.
Okay.
This
I'll
first
just
one I'm
work
like
through.
stalled on. Yeah. All right. So just to check, it's 10:35. So and we spent an hour and a half on these labs, which is totally fine. But we are now starting to, we're going to be missing lessons now. We're going to start like having to drop lessons in order to, we won't be able to finish during the day. So we can keep going and push on this if we want to, or we can move on to the next like lecture and lesson around like Helm and networking and all those other pieces. So I'm just kind of throwing that out to the group, is that we might have to stop. Yeah.
I would say the this pull rate limit is kind of destroying the lab time. I would say forget the labs and go to lecture.
I think Docker needs a break from us.
Indeed. All right, well, let's give them a break. So let's leave everything as is. Don't necessarily have to like change or delete anything, right? So, yeah. Sorry, just looking through everything else. Okay. All right, so then let's take a quick break because I think we've been going full bore for the thing, right? So let's do this. Is that it's 10:37 right now. So let's take a 15-minute break and let's just make it an even number. So let's come back at 5 till. So we'll take a little bit extra. So let's come back at 5 till. We'll go on to networking. I'll see if there's something else that can't be done there as far as like the rate limiting piece, but
is there any way to automate the rate limiting piece, like a script that we can just copy and paste and run? Something like that.
like to automatically like pull it down to the whole thing. Sure, I could write a script for that.
Or to automate the creation of the secret or whatever it is.
Oh yeah, absolutely. That'd just be a matter of taking everything we did in the command line, just sticking it in a script. That would be simple. So
just we all don't have to recreate it.
Okay. All right.
As long as we're talking about the rate limiting thing, one last question. If I have a pod that is pending startup because it can't download an image, is it going to continue to keep trying to download that image periodically?
It will. It'll do an exponential back off, so it'll be random, but it'll just sit there and try at random intervals. The intervals will get longer the longer it sits there.
Okay. So eventually it will succeed, and then I will be able to carry on.
Yes, if the rate limiting is, if the authentication is enabled.
Okay.
Cool. All right. Sorry for that frustrating lab, but thank you for sticking with me, especially for those who didn't actually get to completion. So again, let's stop. We'll come back at 5 till, and then we will resume networking from there. All right, so let's talk about one of the most complex things after that awesome lab around Kubernetes, which is networking, right? So networking and security. So security, we barely even touch in this class because it's like its own kind of thing, honestly. But networking is also can be a cumbersome beast depending on kind of the approach that we take to it. So let's talk about it. So the first thing to remember is that, all the basic components you need to be aware of. So you need to know, obviously, what containers are, what pods are. Ideally, knowing that services exist whose job it is basically is to act as load balancers, right, for back-end pods. And then knowing what a worker node is, master node is, also known as nodes and leaders, right? And then understanding that an external network is anything outside of the cluster. And of course, the internal network is anything that's inside the cluster, which of course Kubernetes creates by default, right? So the general network model to think of here is that Kubernetes treats pods like they're virtual machines. They have their own IP addresses. They have their own IP space. Anything that's inside of those pods, like multiple containers, they're all treated like they're on the same virtual machine, right? So the containers that are inside of those pods have to expose themselves. And then of course the pod itself may actually be exposed via service, right? Now, the funny thing is, and I think I've said this a lot, is that containers can talk to each other inside of a pod just through local loopback. They can just loop back to port 80 or 443 or 33, whatever it is, right? Doesn't matter. But services are the primary vehicle that expose pods out to things outside the cluster, but they also expose things inside the cluster. So don't get me wrong, services can be internal and external load balancers, although they're not all actually legitimately load balancers. I'm just using that as a metaphor, really. So Kubernetes, by the way, does keep a list of all of the endpoints, like IP, like networking endpoints that are associated with the pods and with any services. So just so you know, all networking is tracked by Kubernetes. So any host can find any other pod or any other service by just simply querying the API server in the etcd database. Hey, I'm looking for this DNS entry. Can I get it? Right? And it's like, yeah, I got it. Right? So the Kubernetes API is the kind of is the enabler for the discovery of these various endpoints. Now, we have a couple of layers of communication here, both container to container, pod to pod, pod to a service, which, the services again acts as a load balancer, and then by people coming external to the pod external to the cluster into the cluster, which basically they're coming through a service. So with container communication, that's just really simple. It's like the same, like having two applications talk on your laptop or desktop. They're just going through the same network stack because technically they are on the same network stack, right? So containers, by the way, are not isolated from each other. Containers that are in the same pod have practically unfettered access to each other. So if you're worried about a container and its security, and you got another container that contains sensitive information, you're not going to stick them in the same pod. You're not going to do that because that's going to weird you out because you're not going to have any security for those particular pods, right? Sorry, for those particular containers. So what this means is that applications in containers that are in the same pod have pretty much unrestricted access to each other, right? You're not limiting that, you're not blocking it, you're not doing anything to it, right? Because they also have a shared memory space and they have shared access to storage. So just know that might be another reason why you put one application per pod, because the pod is not just the basic unit of deployment, right? Or the basic unit in Kubernetes, it's also the basic unit of isolation. So just know, container to container, no limits inside the same pod. Now, if pods get their own IP address, one question is like, are these IP addresses public or private? It just depends on how the network is set up with Kubernetes, right? But pods do communicate together based on their IP addresses. So you actually do have to, like, you know, it's either through DNS or direct IP access. They're going to talk. And if the pods are on different hosts, that doesn't matter. It just goes out the host and goes into the other host. That doesn't make a difference. Kubernetes treats these pods as if they're virtual machines. They all have their own unique IP address. That's no different than what we do with our laptops on our networks. And by the way, the pod addresses are not simply private to the node, which means they are advertised, right? Meaning that other hosts can find the IP addresses that another host is hosting. So, and if it's a public IP address, right, you can get to it. It's not a problem. Now, pod to service communication. So we've gone container to container inside of a pod. We've gone from pod to pod, right, on multiple hosts. Services allow you to group the same pods together. So if I've got 10 Nginx servers and I want a single entry point into those 10 Nginx servers, that's what a service is. A service is yet another IP address that if you hit that IP address, the service is going to distribute traffic to the backend pods that are associated with it. So the service is going to create a virtual IP address and it's going to act as a single connection point into all of the member pods. You know, one of the best things for this is, let me pull this up really quick. Let's talk about networking. You already open? Is that why you're doing that? Funny. One of the best things for this is no, not looking for that. Looking for this. Yep, here we are. Okay. So here we've got, for example, two pods talking to each other. So we're going to go back to pods for just a second, right? So you've got a pod over here, right? And a pod over here. And these are all on the same host. They're on the same host. We have not left this little orange box, which is this host, right? Now, what happens is that when these two pods want to talk to each other, they're actually going to go through like a virtual switch that exists that Kubernetes has put on each of the hosts. There's a virtual switch. And so that switch is just going to allow the pods to talk to each other on the same host. If we're on different hosts, that virtual switch, that VTH0, is going to allow it to go out the interface, right? It's going to go out the interface. So this is two separate hosts trying to talk to two separate pods, right? What's going to happen is that the pod over on the left-hand side over here, actually notate that, over here, let's say it comes out, it goes out the network interface, comes over, and it wants to talk to this guy, so it goes through all this. Now notice, just to say this, is that there's an IP address here for the pod. There's actually another IP address, the same one, just so we're clear, it's the same one, but like the same IP address is here attached to the virtual switch. And this same IP address is being advertised by the host that the pod is sitting on. So everybody can find everybody. Everybody knows where everybody is because the IP addresses are being advertised across the network. So if this guy over here says, my DNS resolution says I need to go over to 194, It knows to talk to this host, which is going to talk to this virtual switch, which is going to talk to this pod. Does that make sense? Right? All the signposts, all the addresses are being advertised constantly. Paul, did you have your hand up still because you had something to ask? Just want to check.
Yes. A service is a group of pods. I thought that's what a cluster was.
A cluster is a collection of nodes that are hosting common software.
Collection of nodes.
Yeah. And by the way, they don't have to be nodes. Basically, it's applications that are basically serving a common purpose, right?
Okay. So it's
Yeah. But hold on services. We haven't gotten to services yet. We took a step back for a second. So hold on just 1 second. I bet you we'll clear your question. I'll bet you we'll clear your question up. I'm hoping we will. Okay, so we're still actually on pod to pod communication, but this shows how it works. There are virtual switches here in addition to the network cards that are on the host, and everybody is advertising everybody's location. That's the main thing you should know. So you don't have to worry about like, man, this pod is like 3 layers deep. It's like Inception inside of Inception, right? How do the hosts like know where the pods are? That's because the hosts are advertising the IP addresses of the pods. Do you see now why you can't run more by default out of the box 100 pods on a host? Because this host, if it had 100 pods on it, is advertising 100 IP addresses. It's running 100 virtual switches. And in those virtual switches, it's doing process isolation for 100 pods.
It's a very busy node.
Yeah.
Yes.
Question.
Yep.
And this may sound crazy, but does each host need to have its own a NIC per IP
No.
in order for it to work? Okay, good.
Nope. No. Yeah, not nowadays. That probably was true like, 20 years ago or something. But like, I got to tell you, we keep, I think because of the level that I operate at, I usually am not like that far into the networking. It is shocking how far networking has progressed, honestly. Like the things they can do now really just blow my mind, honestly. Back versus when I was like a Cisco switch administrator, right? So basically all the IP addresses are just stacked onto the same physical card or, virtual card if it's a VM. Yeah. And by the way, this all conforms to the container networking interface standard. So the CNI standard has defined by the OCI, right? So there's a container networking standard, there's a container storage standard, there's a container runtime standard. So like you've seen it, but just so you know, there's a bunch of standards here that are being adhered to. No one's violating those standards if they want their stuff to work, right? So by the way, when any of the providers say this is a certified Kubernetes distribution, it means that it's conforming to all of the standards. So if you ever decide to use a managed third party and they're not certified, you should find out why, because that might cause problems for you. But just so you know, I can't name one off the top of my head that isn't, because they all are now. Okay, so just to go back, container to container communication is super easy because there's no barriers. There's no translation. The applications are sitting on the same stack. If you are on the same host, it's just going to communicate back and forth inside the host. It's never going to leave the host. If you're on different hosts, it's going to leave the network card for the host and go talk to the other network card for the host that's hosting the pod that you want to talk to. This, by the way, doesn't work any different than it does actually for any application talking to any other application on another host. The only difference is that there's extra layers of IP addresses in virtual switches. Okay, now here's where we get to services, which is kind of an interesting topic of discussion. Because the interesting thing here is that services solve the issues of pods disappearing and new pods being created with different IP addresses. So instead of telling like say someone wanted to hit your website and you're hosting on Kubernetes, instead of telling someone either DNS or otherwise the IP address of your changing set of pods at host Nginx, you're going to create a service. The service is going to get a consistent IP address and it's not going to change because it's going to stay up. And if it crashes and comes back up, it has the same IP address. So a service is a way to provide a consistent IP address so that people can actually get consistent access. So think of this service like right here. So what happens is that people are going to come in, right, to this service. Now, cluster IP is a service. Node port is a type of service. Load balancer is a type of service, and external name are all types of services. But if you were to visualize this as a customer comes in and they come back over here, what they're doing is that, let's say there's 4 pods in our setup. There would be a pod here, a pod here, a pod here, and a pod here. If one of these suddenly went away, the client wouldn't know. They would actually go to another pod. If 2 of them went away, they wouldn't know. Client would go to another pod. If all of them go away, well, the service wouldn't work, so people would know there's something wrong, right? They would know at that point in time. Okay. Now here's where things get even weirder, right? Is that if services provide us a consistent access point to get to pods that are constantly changing and moving around and getting new IP addresses, so services are just there to create consistency, right? What happens is that these different types of services all do very like remarkably different things. So for example, if I was coming in to, and I'm going to erase this actually, because why not? If I was coming in, all I had for a service was a cluster IP address. That means that there would be a bunch of associated pods associated with this cluster IP. And out of all 4 types of services, cluster IP, node port, load balancer, and external name, the cluster IP is the only one that's internal. So this one is internal access only. In other words, if you're coming from outside the cluster and you try to use that service to get, you can't touch the cluster IP service. This is only used for internal distribution. So let's say I was inside the cluster and I've got, let me change colors here, just to make that easy. I've got a web server up here and it needed to talk to the application servers in purple. What would happen is that this guy is on the same cluster as these guys. It would hit the cluster IP and the cluster IP would route traffic to one of these at a time.
You said the cluster IP is not accessible externally?
No, it's not accessible externally. Now,
So
this is in production, right? So for Minikube, it's a little different, just so you know.
what does the blue oval represent? Sorry?
Web server, like let's say like a web server, for example.
Okay.
And say the red things represent like an application server, like a Java server or something. But these guys are all on the same like cluster. So they're all in the same cluster. So out of the 4, the cluster IP is only used internally. That's it. So only services that are in the cluster can hit the cluster IP to get access to the rest of the cluster. That's what the cluster IP is used for. Just for internal load balancing. That's it. So that's what you need to remember is cluster IPs are used for internal load balancing. So some people, because by the way, that doesn't make sense because most of the time when you have a cluster IP, it actually exposes it externally. And every other technology I've seen, when you say, hey, this Oracle rack cluster, here's the cluster IP for the rack, that actually exposes the thing externally. Kubernetes is the only service where it has a cluster IP that I've ever seen, and that cluster IP is internal use only. It actually does not give you external access. Now, the rest of these all give you external access. So while this guy is internal only, the rest of these are all external possibilities. What does that mean? So let's take these one at a time. So node port is interesting because node port basically says, so for every single node in the cluster, actually, let me have a few. For every single node in the cluster, I'm going to bind to this, like, to the same port. So for example, That means that if you bring traffic to any of these nodes and you hit this port, it's going to go to the pod. Or it might actually redirect you to another pod. You follow me? This one, by the way, is fraught with peril, and here's why. What if that port's bound? Imagine you have 10 worker nodes in your cluster. You got 10 application nodes. And someone says, you know what? For this set of pods, I'm going to run 10 pods. I want you to listen on 8,000, just as an example. 8,000. So you come in and you start the pod and you start this pod and you start this pod, but then this one fails. You know why? Because somebody else is using 8,000 on that port. So then it has to jump to another host to see if it can find a listening 8,000 on the port. Now, don't get me wrong, Kubernetes randomizes this to death. And so conflicts are relatively rare. But just to say this is that, you know, you're going to get a bunch of random port numbers and they're going to be bound across the stack. And again, now you can see why you only get 100 pods by default out of the box per host. You get 100 pods per host out of the box, because this is the kind of networking oddness that Kubernetes is doing if you decide that you're going to do node port. Now, just to say this is that most people don't use node port. Here's what they do instead, is they run a load balancer out here, right? And what happens, and you're going to laugh at this because it is kind of silly. Actually, let me erase this piece. Is that this external load balancer, so this is obviously used with like cloud providers and stuff, although honestly, you can run a cloud load balancer internally. What this load balancer does, this is great, by the way, it actually hits it actually listens on the node ports of the systems. It actually is listening on the node port, which in turn leverages the cluster IP. So the load balancer actually flows to a node port, which then flows to a cluster IP, which then hits the pods. Did that seem convoluted to you? Let me say that again, just in case you missed that. When you add an AWS load balancer into the mix, because you've told it that you want to create a service called, and the type is equal to load balancer, what happens is that it automatically creates a node port for you, and it automatically creates a cluster IP for you. And what the load balancer does is this load balancer up here registers these node ports as its targets. And then once it hits the node port, it'll actually redirect to a cluster IP to distribute the traffic across the cluster. So if you hit one of these systems, you're going to hit all the pods that are on the system relevant for that service. If you hit one of these systems, you're going to hit all the pods. You're going to hit one of them, obviously. You know what I mean? You could hit all of them if you needed to. If you hit one of these node ports, you're going to hit all of the pods that are on that system relevant for this service. So do you see the ridiculous meta that's happening here? Let me blank this out. Let's do it again, because this is crazy. So the load balancer is here, and it's actually an external object. Like an AWS load balancer, an Azure load balancer, or the Google Compute load balancer. It's an external device. It could be an F5, by the way, or whatever. Doesn't matter. When external traffic comes in from the outside and hits this load balancer, the load balancer is going to hit one of the node ports on a particular node, and that in turn is going to hit the cluster IP address internally, right? Because this is internal. Cluster IPs are internal only. I just said that. And then what's going to happen is that the cluster IP is going to pick a pod to talk to inside the cluster. The next time traffic comes in, what will happen is that traffic will hit the load balancer. It's going to hit another node port, maybe on another node, which in turn is going to talk to the cluster IP address, and maybe this time it's going to go to this particular pod. Traffic comes in again externally, hits the load balancer. the load balancer hits yet maybe the same node, maybe it's the same node on the same node port, that hits the cluster IP address, and this time it goes over here to this pod for that particular piece of traffic. Does anyone think that that's simple? Because I would love to talk to you, because you have a future here with Kubernetes networking.
The red boxes at the top are
Pods.
Are node pods.
Yeah, so these are pods. Oh yeah, you're not gonna let me do that? That's weird. Yeah, so these are pods. All of these are pods.
You guys hear me?
We can now, yes. Hi.
Oh, sorry about that. Yeah, I was just saying like the drawing in, I guess in general, doesn't make that much sense only because when you drew the pods up there, it looks like they're external to the internal, what looks like it's internal to me in the green, right? So
Yeah,
I
fair enough.
get what you're saying. So on a normal AWS drawing, you would have like the load balancer, it would hit the node port and then it would select whatever port it deems necessary, and then it'd go to the cluster IP, and then within there you'd hit one of the. Yeah, that's a little better, I think.
There we go. Perfect.
Yeah. And
Good.
the cluster IP is a service.
The cluster IP is a service, but unless you explicitly create it, it's created for you. Like when you create these other two types, the cluster IP is created for you.
Can you go over node port one more time?
Sure. Okay, so node port basically is if we look at each host in the cluster. Let me actually add some hosts here to make this easy. We're going to leave this drawing alone for a second. If I go back and I add, let's say like this whole thing obviously would happen, let's say within a host. This node port right here would actually be a port on the host. In this case, let's say it's like, 5577, right? And there could be another port on the host, right? That let's say is, I don't know, 6601. What this means is that this particular host, which actually does have access to a cluster IP and, maybe the load balancer is external, obviously, but the node port's on here, right? What this means is that when the load balancer comes in, like let's say the load balancer comes out and then comes back in and hits the node port, let's say it was 6601 and that's bound to that particular node, it would then hit the internal cluster IP address and then it would go to a pod. So when traffic came in and hit the load balancer, again, visualizing the load balancer as external, it would then go and hit the node port of a particular host and then route to cluster IP, and then it could hit another pod at any given time.
Okay, so you just said something. So the load balancer is external?
Load balancer is external, right?
Okay, gotcha.
Remember, I'm just showing you how these things are stack onto each other, right? But the load balancer is actually an external object. It's exposed externally with a cloud provider's load balancer, basically. So you either need a cloud provider's load balancer or you need to run your own F5 has the load balancer type that Kubernetes is going to leverage. So this particular piece right here is actually an external object.
Okay, I'm tracking now. Thank you.
Yeah. So imagine this load balancer sitting right over here. This is where it's at. Actually, I would prefer a solid line. Let's do this instead. That's where the load balancer is at. All right. So traffic hits the load balancer. The load balancer hits a port on the actual host called a node port. It then routes to a cluster IP address, which then routes to one of the pods that make up that particular application. So remember that a service is just an entry point for a bunch of pods. That's all it is. So if you use a cluster IP, it's internal only. If you use a node port, it binds of that port across all the hosts that the pods are running on. And if it's a load balancer, it's actually an external object. Now notice that we did not talk about external name. And the reason for that is external name is actually a lot more simple. External name says, basically it maps a DNS name and it returns a CNAME record. So basically what happens is that in DNS for Kubernetes, if someone says, hey, wait, where are you? Someone says, hey, I am this pod right here, and I'm actually looking for a database. External name basically refers you to something outside the cluster. For example, RDS or DynamoDB. Or whatever you wanted to put in there, right? So external name basically just acts as a redirector. That's all it is. It doesn't actually do any load balancing. It just says, hey, if you're looking for, database.michaelforrester.com, just go over here. That's where it's at. That's all external name is it redirects you to the outside. You might say, well, why wouldn't you just use DNS for that? If you create a service, by the way, in whatever DNS and whatever changes, especially if it's something ephemeral. But if you do it here as an external name, it shows up inside of the service discovery for Kubernetes, meaning you can just type the simple name and it'll go find it. You don't have to type in the fully qualified domain name. So that way you can refer to it in your YAML specifications as well.
Maybe it's just me. I need to do it and see it.
Yeah, it's almost impossible, but yeah, because you actually can't peel it back. Actually, the only way to do it is to go through the code. Even, by the way, doing sniffing and stuff like that is really hard in this environment because everything's so segmented and isolated. Again, it's not necessarily impossible, but it's really hard to pull off.
You blew my mind, Mike.
There are whole books written on this, and oddly enough, that's as far as we have to go, right? I knew that there was going to be trouble with this when someone published a Kubernetes networking book, not a book on Kubernetes, a book on Kubernetes networking. I can't remember the name of the gentleman who did it. I was like, man, this is going to be a disaster. We have a whole book for Kubernetes networking. This doesn't even begin to cover like pod security policies and admission controllers and all the other stuff that's in there. So when external access is stated, is that referring to external to the node? Yes. Yeah. That's true, Kevin. All right, other questions?
You have to use this, or there's a workaround?
I would say that most of the time people just use the load balancer service type. People do use external name if they want to redirect to third-party services. But if you're integrated with a cloud provider, all of this goes away. It's not that it's not there. You just integrate with an external load balancer and you're done, right? And since Kubernetes is cloud aware, it will manage the load balancer for you. So things get hairy like this when you do it manually, which just to be frank is the worst way to run Kubernetes right now, because it's still actually too complex. It's still actually too complex to install, too complex to manage, and too complex to troubleshoot from my perspective for mainstream adoption. But people keep pushing it. But this is why, by the way, the most common, by far, the most popular installations of Kubernetes in the world are in the cloud. Because, like as an example, Amazon, you don't have to touch any leaders for Amazon. All the networking is handled for you. You know what you do? You basically tell it, set policies, basically your standards, and then you just deploy stuff and you're done. You just move on.
So there's a workaround.
Say again, Mita?
I said so there's a workaround, go with AWS or cloud. Okay, got you.
Yeah. Last thing I saw is that 85% of the installations in the world are on cloud providers, not on bare metal.
Okay, thank you.
Excluding messing around, of course, because we're all running our own clusters.
Thank you.
Yeah. Okay, let's see, just to check. I don't think I'm going to talk about this, but I was just kind of curious. Okay, so let's talk about cluster IPs again. So cluster IP back in service, right? On the, basically being advertised. It's routing to the kubelet and then to kube proxy. And then it's basically like just targeting, like this is going from web app and this is going to back end. So just know that, again, this drawing is kind of like interesting. But what's happening is that the traffic is flowing, right? Here's the destination, here's the targets. So in this case, what's happening is that this is basically saying that if you're trying to get to these backends, let's ignore the left for a second. If you're trying to get to these backends, if you hit this IP address, we will route you to one of these backends. That's what it's saying, basically. If you get to this target, we're going to route you no matter where you're at. We're going to route you to one of these backends. That's what a service does. A service says, if you actually try and hit this IP address, we're going to route you to one of our backend services. And now, whether that's a cluster IP address, a node port, or a load balancer, just depends on what level you want to operate at. Most of us operate at the load balancer level and just abstract away the node port and the cluster IP addresses. Cluster IP addresses obviously for internal use only. We were very clear about that before. Node ports are obviously bound to the particular nodes in question, but you got to worry about port collision. Load balancers abstract away all of that. You can get a lot bigger with load balancers than you can ever get with node port and ever get with cluster IP alone. By the way, here is how you define a cluster IP service, right? Notice the kind is the service. So when you do a get, you're going to get a service, right? Notice the ports listed there, target ports, right? So there's actually like two sets of ports here. So both port 80 and port 443 route to 9376 and 9377 on the backend pods. What this is saying is that this service is listening on two ports. If you hit 80 or 443, it's going to route to two different ports on the back end. That's what it's doing. Okay. Very simple definition just for a cluster IP. Now, quick question. Are cluster IPs for internal use or external use only?
Internal.
Internal.
Internal. Cluster IPs for internal use only. Don't let the name fool you. Internal use only. Now, here's an interesting thing. So here's a node port portion, right? Where basically what it's doing is that as external traffic comes in, it's hitting this service right here. Whoops, hold on, that's not what I wanted to do. It's hitting this service. This service, by the way, is bound to port 32001. And what it does is that kubeproxy, remember kubeproxy, the hidden like networking portion that sits on every single node? Kubeproxy says, look, man, if someone hits my IP address and goes to this port, I'm going to send them to one of these boxes. This is a port bound to this network card, to this host, to this IP address. That's the host IP address. It's not this series of IP addresses. It's the host IP address. Now ignore this whole EKS thing. Just pretend it says leader up there, right? But it is the same thing. So every single host, by the way, that is going to be bound with 32001 in the cluster that has those pods running on it. If you let Kubernetes manage that for you, it goes flawlessly. If you don't, then you can run into collisions. It starts getting ugly. Here we're defining a node port service. Notice here it's listening on port 80. The target point is 9376, but you have to say what the actual port that's bound on the host is. That's what the node port is. So if they come in and hit 80, it's going to basically redirect them to 32001 and then redirect them to 9376. So that binds to the node. And then the load balancer is the easiest of the types. Because notice that if they put a classic load balancer here, but what's happening here is that the external traffic is coming in, hitting the load balancer. The load balancer is picking a node that's registered with it, right? And so it's basically picking a node, hitting the, right? So going through the node port, right? Hitting that service, and then it's getting routed basically through a cluster IP to one of the backend services that's associated with it. When you create a load balancer, all of this other stuff is created for you. You don't have to go in and create a cluster IP and then create a node port and then create a load balancer. You don't have to do any of that. That's all done for you by Kubernetes. You don't have to do a lick of that. Okay. Let's go back to our writing for just a second. Because we already talked about external service communication. We already talked about node ports, load balancers, clusters, IPs, and external DNS. We just did the accessing applications one, which was really tough. I already talked about the container networking interface standard, so we already mentioned that just now. So CNI, by the way, is the container network interface, is a standard container network interface used by runtimes. We already talked about that. I mentioned that if it's an upstream compliant Kubernetes, it's adhering with all of the container standards, right? Oh, I don't even know why this is here. No one's going to use that. I'm not sure why that's there. The CNIs, by the way, are probably up for some discussion. Is that you can actually change the type of networking that Kubernetes does by choosing like different types of like container network interfaces if you want them. Just note that that's probably a very deep meta topic. I would probably just use the default Kubernetes networking because quite frankly, it's robust for 99% of use cases. But do note that, you know, there are plenty of options. Everything in Kubernetes is configurable. So if you want to use different storage, you can add storage plugins. If you want to use different networking, you can use different networking plugins. If you want to change the security policies, you can add in security policy plugins. So just know that there are options if you want to change how Kubernetes operates. Out of the box, Kubernetes is actually really robust by default. So, okay. Any questions about this in particular, or intra-host, or just straight up like container to container communication? Okay. So we've already taken a run at lab 10, which is typically associated with this particular piece. And I'm going to just cobble together a short script that's going to bring all those pieces together as far as like, you know, creating the config.json and all that stuff. It should just run, be easy. Any questions about any of this?
So many questions, but I'm just going to do some studying tonight and try to answer them myself.
Okay. Let me know. Let me know. All right. So when we return, we're going to talk about storage. And then I believe that we actually have a managing persistent storage option. And then we're going to talk about Helm. And then we're going to talk about logging, monitoring, and fundamentals. So if we look at the labs that are left, we are going to do a persistent storage lab. We're going to mess with Helm, and then we're going to do a simple CI/CD pipeline portion, right? So that's going to be the rest of the day, right? So it's currently 11:49 right now. So unfortunately, I have to go pick my son up. So we're going to start back at 1, even though we're ending a little bit early. So we're going to start back at 1 o'clock, and then we're going to spend the remaining 3.5 hours covering the last 3 pieces in labs. Okay. So if anything comes up during that time, you know, let me know. We'll capture it up at 1 o'clock, but we're going to meet in exactly 71 minutes. So any final questions or anything else that needs to be said before we stop? Okay.
Can you put up the timer like you did before? I thought that was cool.
Absolutely.
Thank you.